Okay, now we are multiplying two numbers together. You need to treat this as a binomial due to the addition, because you cannot actually add together the root and the number that isn't a root, or even different roots like in number 4. So I'm going to get my pen out. No. I'm going to see if it, of course, I'm always having problems with trying to get it working the way I want. Okay. 2 plus root 3 is one of the binomial expressions, or basically just it has two terms. And then 7 minus 2 root 5 is the other thing that's multiplying, and it has two terms. And you probably remember box multiplication. This box is for 7 times 2, and you will get 14. And then this box is for multiplying 2 times negative 2 root 5. And I'm going to start by writing, I'll just write the two of them multiplied next to each other. This negative sign means the result we're getting is negative. The 2 that I am highlighting right now, that 2 is not inside of a square root. That means I can multiply it by other things that are outside a square root and also multiplying. I'm going to put in a blue highlight for the second term, the number that is outside the root and I can multiply together, the highlighted in yellow 2 with the highlighted in blue 2 to get 4. And again, that negative sign, when we multiply positive times the negative, we get a negative. The root 5, I'm just stuck with 5 under a square root. I cannot simplify that. Then I'm going to move on to this box. This box is found by multiplying 7 times root 3. And I cannot bring together a number outside the square root with a number that's under a square root and actually multiply them. And there's nothing I can pull outside the square root, so I'm highlighting in green. I've got a 3. 3 is not divisible by any perfect square number that I can get to come out of the root. Then, one final box, I'm multiplying negative 2 root 5 with root 3. If I were adding these two numbers, I would not be able to add root 5 and root 3 together. To add, I have to have the same index, which in this case both are 2's, and I have to have the same number if I'm adding. But if I'm multiplying, I only need to have the same index, which is an understood 2, where I just highlighted. Since they have the same index, what I'm essentially doing is using the distributive property of multiplication. Or sorry, let me start that again. The distributive property of exponent over multiplication. Exponent and root are just opposite operations. So I'm using the opposite operation of exponent, a root. I can distribute a root over multiplication and make it separate root 5, root 3, multiply. I'm bringing them back together under the root, and I'm allowed to do that. Then multiplying the 5 and the 3 give me 15. I do need to check, is there any perfect square number that divides 15 that I can pull out of the square root? No. Then, once I have filled all 4 of these boxes in, I then need to add them together. So, box number 1 that I just starred is 14. Box number 2 is minus 4 root 5. Box number 3 is adding 7 times the square root of 3. And then lastly, I have minus 2 times the square root of 15. If I'm going to bring any of these terms together, they have to have exactly the same root index, and they have to have exactly the same thing under the root, and none of them have the same thing under the root. I cannot add them together. So that problem is done right here. I didn't need to necessarily rewrite it, but I wanted to get off of the highlights where I was explaining why nothing more can be done. Now I'm going to move on to the next topic. And this is very, very, very important. We're given the function h of x. It's being given to you as a table and as a graph, and you are going to be filling in this table and graph. By the way, let me make sure it's clear to you that this is the h of x function sitting right here. And I just realized that I failed to have the h of x label sitting on it. So both of these, you are looking at h of x. Now, here's the tough thing. I have presented for you the y column. I want you to see that this is the same as the y column that I have for h of x. And what you want to realize is whatever is inside of that h function, and it's just x, these are the values that go into the h function to give me these blue values. What that means is, and let me change to that, and I'm going to put this screen up where you can see a little bit more. If these are all values of h of 2x, then these are for when these are what 2x is equal to. Know that what I'm taking you through is not the easiest thing, but once you get the hang of what you are supposed to do, it becomes easier. It's not as hard as what this is getting into, why the graph is affected the way it is. Ultimately, you're not going to have to go through these tables. You need to know what to do to the graphs. Does this make sense so far, what I have?
Ms. Blanchard, I have a question.
Yes.
It looks like the numbers in the 2x column are just, they just look like the x coordinates. Like
yes, they are.
The graph.
Mm-hmm.
You put them in the 2x?
Yes, I did. Because let me go to my draw, and I'm going to do this. I highlighted both of those two x's. I'm now highlighting those two original x's. What you want to understand about this table, and let me see, what color should I choose? Okay. Whatever sits here is a variable. Yeah. Yes. What is your question?
Wouldn't it be double because it's multiplied by the x? It'd be like -4, -2, 0, 1, 2, 4, 6, 8 because it's doubled, right?
You know what?
There's the 2 just there for show.
You know what? Let me actually finish the table on 6, and then I'll go forward with you on it. So let's do this. If by chance 2x is equal to -2, what is x? So
repeat that.
Yes. If 2x is equal to -2, what is x equal to?
1 or -1.
Yep. If 2x is equal to -1, what is x?
-1/2.
Uh-huh. If 2x is equal to 0, what is x?
0.
Yes, you got it. And then I'm just going to keep going. If 2x is equal to 1, what is x equal to? And you guys, good. If 2x is equal to 2,
1.
there you go. If 2x is equal to 3,
That'd be 1.5.
yep.
Technically.
Mm-hmm. And if 2x is equal to 4, then x is
2.
2. Now, here's what you want to understand. And first, I'm going to erase some of the excess highlighting, if I can manage to do that. There we go. I'm also wondering if I can get these circles out. Oops, I lost one. Nah. Okay, maybe I should. Anyway, so here's what happens. We have x equals -1, and I think it might be best if I highlight. X equals -1 is located right here on the graph. If x is -1, 2x is -2. Whatever I put into h's input, this table over here is going to take input and give me output. I'm going to erase. So see if you can follow what I'm trying to show you. If I put -1 into x and I multiply it by 2, and I then ask what is h of 2x, h says, what are you putting in me? And it's confusing because I'm using the x variable in both places. That actually makes it confusing. So I have, what is the input for h of 2x? It is -2. When -2 is the input for h, I get -1 out. And then I'm going to keep talking. Actually, let me plot that point. And I want to make it a little bit bigger. so I can plot a point easily. When x is -1, I get a y value of -1, and I plot that point. But I want you to realize that the original h function got out the y value -1 when x was -2. Now, when x is -1/2, if I multiply that by 2, I get -1. Then if I say my input for h is -1, h will say I will give you 0. That means for x coordinate -1/2, the y coordinate is 0. Now if I put in x coordinate 0, and I multiply that by 2, it's going to still be 0. If 0 is my input on h will give me a value of 1, which happens to be the very point that it was before. Know that what I'm trying to do is sketch the graph of h of 2x. We have in the past taken a function and done multiplication with the y. If I take a graph and I multiply it by 2, I vertically stretch the graph by multiplying all the y coordinates by 2. I want you to be able to see with these two problems. I am not expecting this to make sense the moment you see it. What I want you to do is allow this to penetrate your mind. And again, it's not going to happen right away that you're going to see what I'm trying to show you. Now, I'm going to go now to the next point. If x is 1/2, then I am looking right here at x equals 1/2. If I double it before I plug it into h, that means that I'm actually plugging 1 into the h function and getting 2. So when x is 1/2, I'm getting 2. Now I was getting that number when x was 1 with h. And what I'm trying to get you to see is that if I, instead of multiplying outside the function by 2, I multiply inside the function by 2. What that does is it takes a graph and horizontally squishes it in. It divides the x coordinates that you have by 2. And then this, the next point. Where am I? So when x is 1, I double it and I look at what does h give me when I give it 2? It gives me 0. Then I plug in 1.5. I double 1.5, and that is the number that goes into h, and h tells me -2. So I plot 1.5, -2 as a point. When I plug in x equals 2, I first double it. Then I ask h, what do you give me if I give you 4? And it says -4. And all the in-between points will be doing the same thing. I want you to take a good look at that graph. And I'm trying to help you understand why this happens. But what you need to know is, if you have the graph of a function h of x to begin with, but you multiply the x by 2 before it goes into the function. What you actually have to do is take all the x coordinates that you see and divide them by 2 instead of multiplying by 2.
So let's say instead of 2, it was 3.
Mm-hmm.
You would have to divide each of the x coordinates by a 3 and
Yes.
then put them into the function.
Yes.
Alright.
Yeah. And then you're going to want to reach a point where you can do a quicker answer to this. So in the future, where you're heading to, and I'm going to erase, I'll put the answer back up, but I'm erasing right now. You want to reach the point where you can look at this as h of x, and when you're asked to graph h of 2x, you look at your x coordinates, -2, -1, 0, 1, 2, 3, 4. Take each of those x values and divide them by 2. Keep the y value that goes with the original x. I need to erase so you can see better. So x being -2 has y value -1. I'm going to divide the x equals -2 by 2, and that will tell me how that point got squished horizontally. Over here, when x is -1 on the graph of h of x, I get 0. I'm going to keep the y value as 0, but I'm going to take the -1x and divide it by 2. And that will move it here. Now, when I have my x or my y-intercept, my x value is 2. 0 times 2, basically, I'm still putting 0 into h. That is the one place where the graph will not change. So again, I'm taking the x coordinate of each point. This is the point 1, 2. I'm dividing the x coordinate by 2 and plotting that point. This point is 2, 0. I'm dividing the x coordinate by 2 and I'm plotting that point. And I need to erase the point that I drew for the original graph.
Excuse me?
Yes.
So if we went 2y, would that mean that we would keep the x coordinate the same, but the y coordinate would be half?
Hold on. You said 2y. And I'm trying to figure out what you mean by that.
Like the 2x portion that we have,
Uh-huh.
replaced it with the 2y instead.
Okay.
Using the y coordinates, would we do the same process?
That's getting really deep in, and I want to be careful about this, because if you're looking at it that way, you are working with a function where you have switched what x and y actually mean. And we're not going to do that in this class. We did that when we talked about inverses, and that is as far as we will go. The inverse functions swap their x and y, but I'm not going to have you swap and manipulate. That's too much. The only thing you're going to be dealing with is you have some function. You might multiply outside that function by 2. You've done that before. If you multiply outside by 2, you're going to double your y coordinates. So y coordinate, I'm also looking at the time and kind of realizing where we're at. This is, once this starts to make sense, it won't be too bad. And I know that I'm running out of time at this exact moment. So maybe what I need to do is make a video to help talk you through this so you can finish the classwork tonight. Okay? Because we've got 2 minutes left of class, and I can see that there is a lot of confusion at this point. Yes, I see a hand. Parker.
So I'm just at the homework 2.5, and I was curious.
Mm-hmm.
Basically, the last page. It's not a part of the class. We're very confused.
Let me see what you're talking about.